Okay guys, so this is the result of part 1 of this video, yeah. Two of these things basically doing the same thing now, which is powering on and powering off again. And I hear this is the time for a little less conversation, a little more action, apparently, as Elvis once said. So let's move on a bit with this. Got a couple of ideas in mind as we can try. Without just starting to remove all the capacitors and test them, which we might end up doing, and other things. Yeah, but first of all, this is the little controller board, yeah, that I desoldered the other day, and I'll just zoom down on this one. So I asked some of the guys on Badcaps forum, badcaps.net, which is a free forum, yeah, and one of the guys there used to work for the company. It was a parent company to these, and he is 99% sure that this is the pulse width modulator controller. But he also says it's not one that you could, it was like specially made ASIC, application specific IC, and you probably can't get replacements for that, which sort of makes sense. I can't even find a data sheet, or anything on that. So I've no proof or reason to say that this is the problem. In fact, this works. I mean, it does power up, so probably this chip's okay anyway. I think it's just seeing something it doesn't like and shutting back down again. Whether there's something it doesn't like as real or imagined is another matter, yeah. Anyway, so we'll put this board back on the power supply, but just before I do that, there's 4 little capacitors on here, so now's a good time just to remove these and just to check and make sure they're okay. I mean, they look perfectly good, but we can't say they are. So while we're at it, let's just remove these 4 capacitors, check them. If they're okay, we'll stick them back on. We'll put this back together, and then we'll try and get into the nitty gritty of this. Okay, see you in a few minutes. Okay, so I've taken the capacitors off, all 4 of them, yeah. Just quite interesting. See how these are marked? So like one edge has got a white stripe, yeah. And that's actually the negative side of the capacitor. It says plus and minus as well on them, plus minus. Nothing wrong with that. It's just a bit unusual. These are marked just with the thick white bit, which is a negative again. Doesn't say plus minus. So yeah, just thought that was a bit different. Okay. So I've taken the capacitors off. So we just need to check these out now. Yeah. So let's have a look on the capacitance meter. I'll need to zoom this out just a little bit. So here's the capacitors. We'll just check them for capacitance in the SR, yeah. So this one's 100 microfarad, 25 volts. Let's have a quick look at that one. And then the other one's a 10 microfarad, 25 volts as well. So it went just like over. I think it's probably just a bit of a bad connection on it, Let me just get this so I can do it without touching both leads with my fingers at the same time. Yeah, 105, that's about right. Let's have a look at these. Black to negative, yeah. How's this one reading? I mean, that's close, but I tend to find, electrolytic capacitors are never very close tolerance, but I tend to find that they always read a little bit over. And when they read a little bit under, I suspect them. We'll check the SR. See, that one's different. Oh. 8.9. I'd also expect them to read basically the same. Yeah, these 3 are all the same capacitors. Let's have a look at this one. Hmm, 8.7. Let's check the SR on these. Yeah, so we'll just start with the 100. I'm a bit suspicious of them 10s. The fact they read different capacitors a little bit and makes me wonder if the SR's out. Well, that's a good capacitor, 0.176. Nothing wrong with that. That's the 100. Let's look at these 10s. That's not good. That's not good, guys. Do they all read different? I wonder. Seems they all read a little bit different of the capacitors. They all read a little bit different on the SR as well. Yeah. Yeah, see, they read quite different. I'm beginning to think this might be played with bad capacitors. Let's let's find some more. I mean, I've got some new ones and I've got some salvage ones here. These are all yeah, 10 microfarad, 25 volts, 105 degree. See if we find something similar to that. See what we've got in here. There's a couple of new ones in here. 10, 25, 105 volts. What do these read like? I mean, a smaller capacitor would tend to read a higher ESR than a larger one, but those seem to be very high to me. Get on there. You see 2.34, much lower. It's one of the new ones. Let's have a look at one to the salvage one, see what these reading. 105 degree, 1025. Even lower than the new one. Right, what I'll do is I'll find three, probably the salvage one since it seems to be reading the lowest, and we'll replace these capacitors. But the fact is, it's like I've got 3 out of 4 bad, and there's the 10 mics that are all bad. Makes me wonder if there's any more of these things around on this board. Yeah, you see, nice and low. Okay, let's find 3 of these, and then let's put this back together. Then we'll put the board onto the PSU. Yeah, and let's see what it does. Let's see if we can get 1 working first. Yeah, that's a little bit higher. I'm sure if I have a bit of a poke around in here, I'll find another one that reads like those two did. Okay, give me a few minutes to do that, and then let's put these on the board. Okay, I found 3 the same. Just want to show you this because this is the point I was kind of making. That if you look at these ones, these will have low ESR, less than 1 ohm. Yeah, like 0.8, something like that. And if you look at one of these on the capacitance meter, you see it reads just a bit more than 10. It reads a little bit over its rated value, and I seem to see this all the time with capacitors that are high ESR. Yeah, and I'm thinking, although it's not a substitute for an ESR meter, if you haven't got an ESR meter, so that one, okay, that now proves it's not quite the case, because that one reads slightly lower than its rated value, but the ESR, I'll check it. Sorry, I'll check it on the ESR meter. Let's just see where I put that ESR meter. There it was. So, I mean, this has got a good ESR, yet it reads slightly lower than the 10, which kind of like possibly defeats what I was just trying to prove, yeah. But certainly the ones that read below the rated value, a little bit below, I think if you don't have an ESR meter, I'll be very suspicious of that, you know, and try to find some that read just a little bit above. It's not as good as having an ESR meter, but I think that'll keep you in good stead, you know. Okay, let's put these back on this board, and let's put this board back into the power supply. Okay, so it's all back together again. So let's have a look to see if this is actually doing the same thing as before. Yeah, so we're getting power on then power off, and the 5 volts is like 4.3 or something like that. Yeah. So let's have a look, see what it does. Yeah, powered on and powered off. I didn't even get to see the voltage this time. It went off before it even showed us a voltage, but I think we can assume it's still the 5 volts, which is, yeah, it's not giving us long enough to see a voltage. But previously we could see that the 5 volt was saying 4.3. And we've definitely had some bad capacitors in here, so that suggests we've probably got bad capacitors all over the place. Let's have a look out of interest. I'll just disconnect the mains power here to see. I'm going to take the ESR meter and I'm going to measure from the 5 to ground, the 3.3 to ground, and the 12 to ground, just as it is. I'm interested to see if we can determine anything useful basically by doing that. Set the ES armies. This is at the connector. So how are we going to do this? Probably have to poke something down the holes, yeah, basically that we want. Let me find a stiff bit of wire or something like that. Okay, so I've got my favourite stiff bits of wire, which are these old 22 ohm resistors, yeah. I got a big bag full of these for free one day to Radio Rally, and they're very useful. Well, that means, you know, not that low really. Just out of interest, let's see what's happening on the 12 and the 3.3, yeah, so orange is 3.3. What's that reading? Oh, about the same. What's on the 12? About the same. Doesn't really tell us anything very useful. Okay. Another thought I have, and I'm just, you know, trying a few thoughts out here, is let's find out where the 5 volts is, yeah, so it's the red wires coming in here, and find the capacitors. And if I've got a suitable capacitor, let's just strap another capacitor across the existing ones, just, you know, temporarily just solder something across there to see whether or not that actually helps it, yeah. I mean, we could start taking these out, but, you know, let's have a look. So the 3 volts is coming down, these are red ones, yeah. Sorry, the 5 volts is all the red ones here, which looks like it comes onto this pad here by the looks of it. I can soon tell just by using the ohm meter anyway, rather than trying to guess, yeah. So let's have a look, see where the 3 volts is going on here. Sorry, the 5 volts. So red wire. Well, the red wires does that come to here? No, it's not there. That's a good job I tried, because it's not going where I thought it was. Looks like it goes here. Yeah. Yeah. So this is the 5 volts here. So let's find like a fairly, you know, big size capacitor and just strap it from here to ground. I'm interested to see if that has any effect on it. Yeah, let's see what it does. Yeah, I think we're onto something here, you know, guys. Look, this is the 5 volts here. So I just use the meter and just measured from the red on here, yeah, to there, 5 volts. And I can also measure this here. So the capacitance meter, that's 2000 microfarads. This is the 20,000 microfarad range, yeah. And I know that on here is some big 4,700s, yeah. So if we go from the red on here to one of the blacks, you'd expect that to read like at least 4.7 if there was only one capacitor, yeah. And it's reading, you know, like 3. And I think the let's have a look at the 3.3 volt as well. That was a 5 volt, that's the one that gives low. So that's reading about 4. What's on the 12? See, that's not reading very much at all. 2 point something. And we looked at the ESR, we're getting about 0.3, yeah. Now, these are a couple of 2200 16 volt, yeah. And let's just for comparison see what they read the ESR on one of these. And it's reading like 0.05, 0.03, yeah. And this was reading like 0.3 something with all of the capacitors in parallel, however many there are, yeah. So, yeah, see, that was even lower. So what I was of mind to do, yeah, let's just try it. I'm going to take one of these capacitors, yeah, the 16 microfarad 2200s, yeah, and I'm going to attach them, if I can, onto each voltage rail the right way round. So we'll stick one down the 3.3 to here, yeah. We'll stick one of them in there on the 3.3. We'll stick another one in here on the 5. Yeah. To one of the blacks. Try and get that in there, yeah. Hoping I'm making a good contact. And then let's get a third one of these, and we'll put it on the 5 volts, yeah. I'll just have to grab another one. Okay, I've got another one here, 2216 volts. So let's stick this onto the 5, so that's one of the reds, yeah. So again, red to one of the blacks, yeah. There we go. So I've attached some capacitors on here now. Just make sure they're all the right way round, yeah. I'm not totally convinced they're all making a good contact, but still. Hopefully some of them are. Yeah, okay. So we put 3 capacitors on there. Let's attach this to the analyzer now. And let's see whether this can power up. So effectively I'm just giving a bit of capacitance on each of the 3 output rails, yeah. Assuming I've got a good contact. At least on some of them, yeah. I'm not sure of that one. Yeah, in there. Yeah, down in there. Okay. Pretty confident this got a good. Contact. That one wasn't. Is a bit wobbly. Yeah. Is it making contacts? I can only hope so. Okay. So that's some capacitors on there. Yeah. Let's connect it back together. Let's see if it powers up now. If it's not conclusive, if it doesn't power up, I'm going to start pulling all these capacitors off here. If it does power up, I'm still going to end up pulling the capacitors off here, yeah? So, it's a kind of like, quite interesting, I think, this is. Just quite interesting, but this could be a useful technique in the future, you know, if we've got a power supply not powering on, if we just do, even before we open this up, we just do this, yeah, if this works. I mean, I don't know, I've not tried this before. Let's have the 12 volts. Let's have the 4-way, yeah. 4-way and 6-way, okay. I think we have everything. One final check, they're all in, they're all the right way round. We're on there. So let's just see what it does now. No, it didn't make any difference. Okay. No, okay. I wasn't. I mean, to be honest, I thought that might have done. You know, I thought that might have actually made this power up. I don't know whether I've not maybe got a good contact on them. You know, they just sort of stuck down these holes, and it's not ideal. Yeah. I'm tempted to give it one more go. Let's just try again. See if we can get this down here. Try that one again. That one wasn't in the oh, that was the 12 volt. It's in there. Okay. Let's see the 5 volt again. Okay. Just off interest. Let's just get one more go at this and let's see if it actually powers up or anything. No. Okay. Right, let's start on these capacitors because they definitely look wrong. Yeah, measuring from the voltage rails, the SR's high, and I don't see enough capacitance basically. Okay, let's make it safe. Wait just for the capacitors to discharge. Then let's start removing these and let's see what we've got. Okay, so I want to pull all of these capacitors out. So I've actually just written numbers on them, yeah, all in order of which way they go across the board. And if I just take a photo of that, I can just now literally take the whole lot out, yeah. I think this will be quicker than trying to do them individually, yeah. So let's just get a picture of what we got here. So we try here. I think I moved when the flash went off, yeah. I think it's just a good way to so we know what goes where. Yeah. Come off. And then I'll see you guys in a few minutes when I've got a big load of capacitors on the desk. Yeah. Yeah. So when I've got a big load of capacitors on the desk, let's see what we've got. Okay, so they removed. Basically, I use like this little, like a little knife type thing, soldering thing to push down into the silicone to effectively separate the capacitors. Yeah, and then just hit them on the side and waggle them and pull them out, and then solder sucker to clean the holes. So while I was doing that, I actually found another one buried down under here that I hadn't marked. So I put an X on that one. Another small one here I'd missed. I put like a coloured blob on that one. I took another photo. All the black edges, yeah, this is the negative end of each one. So we have it. We have one board with all the capacitors removed off the low voltage side, and we have a big handful of capacitors basically. Yeah. So shall we have a look at a few of them? Let's see if we just get them to focus first. Okay, so what we have? Well, we have 3 of these 4710. This little group here are all 2216s, yeah. We've got a couple of 3316s, a couple of 3306.3s, and a couple of little ones. 47016 and 47035, yeah. So that's what we got. Let's check with the capacitance meter first. As I say, anything that reads low makes me very, if it's like just a bit lower than rated, that's suspicious. If it's a lot lower than rated, that's bad, yeah. So that one reads, oh, that reads quite high. So look at this one. These are 4700s, yeah. So let's just check these first. That one seems okay as well. Try this one. Seems fairly good. Capacitance wise, yeah, let's just check these others and then we'll try the SR meter. So these are all the 2200s at 16, yeah. Maybe I have no connection on that one. Let's try it. Oh, reasonable. Looks like reasonable. It surprised me a little bit because I was only reading like quite a low capacitance across the whole lot effectively. Nothing particular here strikes me as being bad so far, but we'll check the ESR obviously. That's the other thing. But normally a high ESR capacitor reads lower than its normal value, and they will read okay. I bet these are 3300s, got a couple of different voltages. Almost. May have bad ESR. Try this one. About right. 2 more of these, yeah. Yeah. And then these are the little ones. So this is the 470 off 35. Put on the best range, yeah. A little bit low that one. Try this one. This is the 470/16, yeah. A bit low that one as well. Okay, let's see what the ESR meter thinks of these. Let's try these two first. Yeah, these 470 mics. Switch this on, and let's see what this is. That's a good capacitor. Well, yes, these are just shorting together. That's seems to be okay. That's low. Let's check this one again. it's not bad, you know, that's not bad. Let's try these big ones. Yeah, let's try these. Wow. Wow. You can fast forward this if you want, guys. I find it quite therapeutic, actually. They're all okay. Looks like you like this lot are alright, you know. This surprises me because, see, when I measured across like the power rails, it seems like quite a low ESR, you know, high ESR, higher than I'd expect. I'm sure you've seen enough of this. Now let's just do the last of them. Yeah, they all look good. Can't see one of them that appears to be bad. There's no other. I mean, I've changed the capacitors on this board. Do I see any on the other side? I have to say no, I don't. I'm a bit surprised. I thought I'd see a couple of capacitors down by this transformer here, yeah, for driving these output devices. And I don't see any. I thought I would actually. Oh, okay, well that kind of got us nowhere slowly, didn't it? So I may as well stick all those capacitors back on, and now let's see if we can find some other way to figure out what the problem is with this thing. Okay, so that really got us nowhere then. I replaced all those, well, say replaced. I put all the capacitors back, yeah, because they all check okay. There's no problem with any of them. And you can see if I power this on, it was doing the same thing, yeah. Power's on, power's off. But now I don't see any, doesn't stay on long enough to show the voltages, but it sort of started doing that before. So I think we can say it's not capacitors. While I was down here, I spotted a power resistor, so I checked that. That's reading okay. It was a 470 ohm. I didn't spot anything that was, you know, looking burnt or sort of distressed under there. Yeah. I think what we can try now, and this is just a matter of trying really, is to just check the opto-isolators, because I don't know about the more recent ones, but back in the day they used to fail a lot. I mean, I'm talking about in the 90s, you know, early 90s, when I used to work on a lot of this stuff on industrial electronics. That opto-isolators would sort of fade, sort of give it up. So it's not difficult to test them. So let's just take the opto-isolators off here, and we have three the same, so that should give us a good indication if they're actually working or not. I've unsoldered the opto-isolators, the three of them here, yeah. These are fairly easy to test, but first of all, let's just check, see if the LEDs are effectively all reading the same sort of voltage drop, yeah. So this side is where the LED is, and the other side is a photo transistor. So from pin 1 to here, I'm on diode range, yeah, 1.01, 1.01, they're reading. Yeah, I mean there's very little difference between them. Yeah. So the easiest way to test these basically is to this is the transistor side of it, yeah. So if we just stick a couple bits of wire in here, yeah, and then I'm going to attach my meter to here. This is the transistor, and leave it on diode range. So to do that, we want a couple of leads with crocodile clips on. Yeah, that's probably the easiest way to do that. Let's find a couple of yeah, here we go, a couple of crocodile clip leads. So we'll just clip one on here, and we'll go to one end of the meter. I'm not sure which way round to put the meter, but we can try it both ways, yeah. I mean, we should see this transistor turn on when we power the LED. So that's one of them, yeah. another lead, another wire. Go on there, and we can connect this to the negative. Yeah. So we now have our meter attached across the transistor. Okay. Now we need to power up the LED. So we need to put a resistor in series and apply some voltage. I'm going to use the bench power supply. I'm going to set it to like 5 volts. Yeah. I'm going to use a 1k resistor because that will give about 5 milliamps, which is probably about right for an LED and an opto-isolator. So let's put the bench. Let's get the bench power supply. I'll set it to 5. You can't see, but you'll see in a minute. I'll show you it's set to 5. Set to 5 volts. So this here is our supply from the bench power supply. If I just take my other voltmeter, just fine. Okay. So I've got the other voltmeter. You can see this as well in a minute. Just set us to voltage range. Some volts, yeah. And let's have you'll see that on the power coming in, this should have 5 volts. So there to there. Yeah, 4.81, it's close. So we got some voltage coming in, okay? The meter's connected across the transistor. So now we'll apply the voltage to the LED and the opto-isolator. Yeah, there, and the black one to here. What we should see on this meter is the transistor turn on. Yeah. So that's reacting. Let's have a look to see if the other two react the same, you know, so they get basically the same reading, yeah. So I can just move these wires down to the next one. Okay, let's apply a bit of power to this one and see what this one does. Oh, that reads different. I would honestly expect these to read the same for, you know, the same type of opto-isolator. Yeah, so look at this one. And that one doesn't read unless I've lost a wire somewhere. Unless I haven't plugged these two into the right place, yeah. So that's 0.227, yeah. Let's take the supply up to about 6 volts, so this will give a little bit more drive to the LED. Yeah, it's still coming through the 1k resistor. What's that give us? You expect it might turn on a little bit more. Yeah, 0.194. Let's try these other ones. What's this one reading? You see that? This doesn't. This one, this middle one. Oh, of course, put the wires on there, yeah. Pressure down the mic wire, here we go. Point 199. I'm interested. I mean, if we increase the drive a little bit, we'll just give it a bit more. I've got a bit more voltage now. Yeah, up to 9 volts. But this doesn't change any. Yeah. So at 9 volts, I should have about 9 milliamps current flowing through this resistor. Yeah. In fact, it's wandering around all over the place. Can you see it? Yeah. 192. Okay. You'd also expect this to be stable for a given current coming into the LED. You wouldn't expect that to change. Yeah, that should be stable, I would have thought. Let's go to the next one again. And again, we're on 9 volts now, so we have about 9 milliamps through the 1k resistor. Just wire into the hole. Okay, go to the next one. Yeah, just make sure the wire goes in the hole. Yeah, bend it a little bit. Okay, that's in. Negative. And again we bring the resistor. Put a bit of current into this one. 2.5. You see, it's definitely, this one is definitely different to the other ones. And this makes me think we may well have faulty opto-isolators here. So we used to see this a lot of times back in the 90s on industrial electronics. That's why I remember it so well. So that one's much lower than 8.1. There's I think it's just a connection. Okay, let's see what these opto-isolators are, the model type. Switch that off. Let's see what we've got. Okay, they're marked SFH617A. Let's have a look, see if we can find a data sheet or anything for these. Yeah. Let's have a look what we've got. And can we actually get any of them? That's another good question. Okay. SFH617A. Yeah. Mouse will have them all data sheet. There's probably some information here that would perhaps give us some idea. I mean, to do with current transfer ratios and such like. I'm not really an expert on the data sheets on these. I just know how to spot bad ones from the past. Yeah. I would certainly consider these to be suspect. Can we buy these things? Are they cheap? Let's have a quick look. AliExpress, yeah, why not? AliExpress, not Sally, AliExpress, yeah, that'll do, close enough. AliExpress, let's have a look, see, SFH617A. Oh, we can get 10 of them for €1.25. With free postage even? No. Okay, so like €2.50 with the postage. Yeah. Somebody else has got them here. What are these? 121. And 121 for the postage. Yeah, about 240. Okay, so we can get these. That's good. The fact that these are reading different from each other really makes me suspect that they're faulty. Yeah, this sort of problem would explain what we're seeing with this. I mean, the only thing is, I'm not totally convinced, is these opto-isolators are on this board, yeah, and this is the PFC, and this is the 5-volt standby, which appears to be running okay, and this appears to be working okay. But I've had a look on the other board. This is the one that has got obviously the controllers on it here, yeah, and this uses a couple of transformers to power the output devices. And I can't. The other thing I can't see on here, by the way, I've looked for a voltage reference, you know, like a TL431, and I can't see one. I had a look around. There was a device on here that I thought might be, and it isn't. I can see two more down here. No, neither of those are either. So I think before we can go any further, we're going to have to change the opto-isolators. This is the other board. This is the last to come off. Yeah, but I think we're going to have to change these. There's definitely something wrong there. They should at least all read the same, and they don't. So they're not expensive. They're like €2. Yeah. So I'll get some of them ordered. For those of you who say no results, well, I'm a bit sorry about that, but you know, when I start on these repairs, I have no idea how it's going to go. Yeah. I mean, there's obviously some engineers out there who are far better than me on YouTube because they fix everything. Yeah, they never fail, but in my experience, it doesn't happen that way. So I guess I'm just unlucky Oh, I'm just honest. Yeah, the sun always shines on TV. Yeah. Okay, so let's order some of these opto-isolators. This is definitely, even if it doesn't fix this one, this is something to learn because, in my experience, these do fail, and they fail in that way that they're not conductive properly. They're not effective. It's like the LED has gone faint, or the photo transistor has lost its sensitivity. I think it's more likely the LED has effectively gone dim, yeah, and that's why this happens. So, okay, guys, I'm going to order some of them. This will go on one side. There will be a part 3 for those of you who you just have to wait, yeah. Those who want to see if in the end we can fix this one. And, yeah, I was right. It's a tricky one. See you now, guys. Ciao.